Hey everybody, it's Mr. Kowalczyk again. So I'm going to video this lesson for 2.4, which is all about special angle pairs. We'll see what those look like in just a minute, but for now we're going to talk about complementary angles. They're so nice to each other. You're looking good today, as are you, my friend. Now, one thing to notice is that we've got here, this is a Greek letter called alpha, and this is beta. We often use Greek letters when we're referring to particular angles. All right, let's move on. Our learning goals are to apply the definitions of complementary and supplementary angles. Again, complementary and supplementary angles. These are going to be our special angle pairs. So we're going to be paying attention to those two kinds of angles. Now, the third one is state, proven, use the vertical angles theorem. So vertical angles. We were talking about this earlier in the week in some of my classes about vertical angles. Today we're going to use the theorem in order to put that into our pocket so we know how to use them. All right, what you up to, kids? Making snow angles. Just reverse the letters there and you got snow angles. Okay. Definition, complementary angles. Now right away we see IFF. That reminds us that we're with a biconditional. Because it's a definition, we know it's going to be a biconditional. If and only if. Okay. Angle 1 and 2 are complementary if and only if the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Complementary is going to be 90 degrees. Complementary angles are 90 degrees. All right, supplementary angles. Angles 1 and 2 are supplementary if and only if the measure of 1 plus the measure of 2 is equal to 180. Now, here's my way of remembering this. You might have a different way. What I look at is this C and 90. C is earlier in the alphabet. It comes before. It's almost like a smaller number if you consider the alphabet like a number line, sort of. I don't know, it makes sense in my brain. And 90 is a smaller number than 180. S, supplementary, comes later in the alphabet, later on that kind of alphabetical number line, if you will, and 180 is a bigger number. So this comes later on the number line. C comes earlier on the number line, if you will, the alphabet. 90 is earlier on the number line. That's the way that I keep them kind of separated in my brain. Maybe that helps. Maybe you have a different way of remembering it as well. Awesome. Hopefully you can figure it out and figure out a way that makes sense for you. Okay, linear pair. A linear pair. Now, this is interesting. Angle 1 and 2 are linear pair if and only if they are both adjacent and supplementary. They have to be next to each other. Sometimes we have supplementary angles that are not adjacent to each other. A linear pair is when they are next to each other. They share a ray, just like this ray here. 1 and 2 share this ray, and they are supplementary because this is a straight angle. Therefore, they are a linear pair. Very specific type of supplementary angle. All right. Moving on. Now, okay, so what we're going to do with this one is let m, the measure of angle 1, equal 4x, and the measure of angle VOS equal 18x minus 7. Solve for x. Okay, so I'm going to flip over to the document camera in order to solve for x for these next two problems. So the first one says let the measure of angle 1 equal 4x and the measure of VOS equal 18x minus 7. Solve for x. Now the first thing I'm going to do is I'm going to pay attention to my special angle pairs based on this diagram. So what do I have going on here? Well, I have angle 1 right here, and then I have angle VOS, which is this angle right here. So that to me says if VOR is a straight angle, which it is, that tells me that angle 1 and angle VOS are supplementary, which means they equal 180 degrees. Now I'm going to write this in marker and pen, felt tip pen, so you can see it a little better. What that tells me, again, is the measure of angle 1 plus the measure of angle VOS is equal to 180 degrees because they are supplementary. Now I'm going to substitute in 4x plus 18x minus 7 equals 180. I combine my like terms and I get 22x minus 7 equals 180. I add 7 to both sides, and then I get 22x equals 187. I divide by 22, and I get x equals 8.5. I'm just asked to solve for x in this situation. I can box my answer and call it good. All right, now using the same diagram, I'm told that this is a different problem. Now let the measure of YOT equal 90. So that tells me that YOT is 90. So I've got my right angle right here. So I know that's a right angle. The measure of angle 4 is equal to 17 plus 2x, and the measure of angle 3 is equal to 4 minus 5x. I'm going to write those in there so I can see them. 17 plus 2x, and this is 4x minus 5. Solve for the measure of angle 3. I'm going to highlight that to remind myself that I'm not just solving for x. Okay, so I have to pay attention to that one. Let me move the document camera a little bit. Give us a little bit more space to see. Okay. Move this up. Great. All right. Oh, no, that's in the way. Now we can't see the diagram. There we go. Okay. So, I know that the measure of angle 4 plus the measure of angle 3 equals 90. Because these two angles are complementary, because they add up to give me this right angle here. Now I substitute in for my values, 17 plus 2x and 4x minus 5. 17 plus 2x plus 4x minus 5 equals 90. I combine my like terms, so I have 6x, 17 minus 5 gives me a positive 12, equals 90. I subtract 12, 6x equals 78, and x equals 13. Now I don't box this because I'm solving for the measure of angle 3. So now I have to plug x in, or substitute it in. The measure of angle 3 equals 4 times 13 minus 5. The measure of angle 3 equals 4 times 13 is going to be 4 times 10, which is 40, plus 4 times 3, which is 12. So that's 52, minus 5. And the measure of angle 3 equals 47 degrees. Box my answer, and we're good. Okay, so that's complementary and supplementary angles. Next, we're going to jump in to a few problems that look like this. Now these are word problems that are going to be a little bit different. So let me rearrange things. We'll get things set up. Hang on. Okay, folks, so now what we've got is a couple word problems. And the big part about solving these word problems is being able to work with them in such a way that you can figure out what each clue we're getting in this word problem. So first off, find the measure of an angle that is 3 times as large as its supplement. So there's a couple things going on in here. First, we have the supplement of an angle. So what I'm going to do is I'm going to draw my diagram. An angle with its supplement. So I have a straight angle here. I know that I have two angles that need to add up to 180 degrees. All right, so I'm going to call this angle 1. I'm going to call this angle 2. Find the measure of an angle that is 3 times as large as its supplement. So what that tells me is that the angle that we're solving for is the larger angle. It's 3 times as large. So I'm going to just say we're going to be solving for angle 2 because the way I've drawn it in this diagram is the larger one. So angle 2 is going to be, we're going to call this 3x. And then this one right here is going to be the supplement, which is equal to x. So this is the angle that's 3 times as large, and this is the angle that's just once, or 1 time as large itself. Now, if we look at both of these things, we can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Then we substitute in and we say x plus 3x equals 180. 4x equals 180, x equals 45. But we're not trying to solve for x. We're trying to solve for the larger angle. So then the measure of angle 2 equals 3x, which also equals 3 times 45. So the measure of angle 2 is equal to 135 degrees. Okay, so this next one has a little bit more going on in it, so we need to be a little bit more careful when we're reading. So the supplement of an angle is 6 times as large as its complement. Find the measure of the angle. So now there's 3 things going on in this particular problem. So we have the supplement of an angle, which I'll highlight in orange, and then we have the angle itself, and I'll put that one in pink. Is 6 times as large. So 6 times as large, that says multiplication, right? 6 times as large as multiplication as its complement. And its complement, I'm going to underline in red. Okay? So we've got 3 different things that are going on here. So let's just draw this out and see kind of what it's going to look like, so we can visualize it. All right, so we have a straight angle, because we know we have a supplement. We have a complement, which is going to be 90 degrees. And then we also have an angle. Okay? Now, I'm not really drawing this to scale, with the exception of the straight angle and the right angle. But this angle here, we're not quite sure how big it is. So we can't assume, can't make any assumptions. All right, so now, what we've got is the supplement of an angle. So the first thing we want to do is we want to describe what that angle is. So this pink one right here, we're going to call this the angle, right? So we'll call that x. We'll call that x. Now, the complement to the angle is going to be the red angle. Now that would be this. This is going to be red. That's the complement, right? Because a complement is going to add up to 90 degrees. And how do we figure that out? Well, we say 90 minus x. Because if this is x and the rest is 90, that's how we get the complement. The supplement of an angle, that's going to be in orange. Now, if we're starting out with our angle as x, the supplement is going to be this angle, and then whatever it takes to get to 180 degrees. So it's all of this right here. This whole thing is going to be the supplement to that angle. And that is going to be 6 times as large as its complement. 6 times as large as its complement. So if this is the complement, 90 minus x, right, because complement is red, we have 6 times 90 minus x. 6 times as large as the complement. Now we're trying to find the measure of the angle. And the angle is x. So, if we look at this, we've got a couple different situations here. What we can do, let's just try to solve for the complement first, right? Because we know that this plus that equals 90. So let's try that and see what happens. We have 90 minus x, and then we add x to that, and that equals 90. Right? Because we have this plus that equals 90. 90 minus x plus x. Well, minus x and plus x are going to cancel out. We're just left with 90 equals 90. And that doesn't help us out at all. So the complement isn't going to work in this particular problem-solving set. So let's try the supplement and see what happens. Well, we have supplementary angles. So we have the measure, we have x, which is this one right here, plus the supplement, which is this one right here. So we add to that 6 times 90 minus x. And that's going to equal 180. All right, let's see if this is a little bit more successful. So first we need to distribute. So we have x plus 6 times 90 is going to give us 540 minus 6 times x is 6x. And that equals 180. All right, let's combine our like terms. We have 540 minus 5x equals 180. We subtract 540. Okay. and we have negative 5x equals 180 minus 540. So 540 minus 180. I don't remember that off the top of my head. 0, borrow. 14 minus 8 is 6, 360. That's what I thought. Okay, so that's a negative 360. We divide by negative 5. X is going to equal 70 360 divided by 5. 5 goes in 35 7 times with 1 left over. Yep, 2. 72 degrees. I was right. I just wasn't sure. I wanted to double check. 72 degrees is our measure of the angle. Okay, this was a good problem. This is pretty complicated. I like this one. Just have to be careful with reading it and making sure that we're doing it accurately. All right. So back to the slideshow now. Now we're going to move on and we're going to talk about the definition of vertical angles. Now remember, we talked about vertical angles in terms of our third and final term for today. So the definition, which I hope you took notes on already, angle 1 and angle 2 are vertical if and only if the sides of angle 1 are opposite rays to the sides of angle 2. Now our opposite rays are coming this way, and that way, and then this way, and then this way, from the same vertex. They share a vertex and have opposite rays going in opposite directions, which means that this is a straight angle here, and this is a straight angle here. It tells us that angle 1 is congruent to angle 2. Angle 3 and angle 4 are also vertical angles because they're on opposite sides of a vertex that share straight angles. That's what we know about vertical angles. Now, the next part of this slide is the vertical angle theorem. This is going to be our third theorem for chapter 2. If two angles are vertical, these two right here indicated in red, then they are congruent. We can mark them as congruent with tick marks. Okay, so notice that this is going to be dealing with congruency here, not the measurement. And in order to do that, we need to work with congruent properties of congruence rather than properties of equality. So what does that look like? Well, let's go ahead in order to look at, we said that postulates we can accept, but theorems we need to prove. So let's go back to the document camera and see if we can prove this particular theorem. Okay, so we're back at the document camera, and now let's prove the vertical angles theorem. So first off, I'm going to go ahead and label angles 1, 2, 3, and 4. And we know that this is a linear pair here because they share a similar ray. This is a linear pair here because they share a similar ray. We also know that angles 2 and 3 are a linear pair because they share this ray here. So we got a lot going on here. So first thing that we're trying to do is we're trying to say that two angles are vertical. We're told that angles 1 and 3 are vertical angles in this particular statement. So the first one we're going to say is angle 1 and angle 3 are vertical. And that's because it's a given. Right there. Now the next thing we're going to do is we're trying to connect angles 1 and angles 3. So what I'm going to do is I'm going to use angle 2 as a bridge between those. So for number 2, I'm going to say that the measurement of angle 1 plus the measurement of angle 2 is equal to 180 degrees. Because these two are supplementary here. But I also know that 2 and 3 are also equal to 180 degrees. So the measurement of angle 2 plus the measurement of angle 3 is also equal to 180. And our reason for that is the definition of linear pairs. So now we've got a bridge between 1 and 2 and 2 and 3. Now for step 3, I'm going to set this equal to this because they're both equal to 180 using my transitive property. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And that is my transitive property of equality. Okay. Now, I'm noticing that I have the measurement of angle 2 and the measurement of angle 2 on both sides. Now I can just subtract those away and say the measurement of angle 1 equals the measurement of angle 3. And that's my subtraction property of equality. Measurement of angle 1 equals the measurement of angle 3, proves that they are congruent. Therefore, we have proven the vertical angle theorem. Yes! Okay, now let's put the vertical angle theorem to work with this last problem. Okay, let's take a look and see what we can do with this one. Solve for x and y in the diagram. Okay, now I know with my vertical angle theorem right away that these two angles are congruent and equal to each other. I also know, based on my definition of a linear pair, that these two angles are supplementary and equal to 180. Same thing with these two angles. They're supplementary and equal to 180 also. So let's go ahead and start by setting these two equal to each other since they're vertical angles. 3x plus 8 equals 6x minus 22. Now, part of the reason why I wanted to do this also is not just that they're equal to each other, but they also only have one variable. So it's easier to solve an equation with just one variable in it, rather than variables with x and y. Let's wait for the focus. All right, there we go. Now I'm going to subtract my 3x from both sides, and I have 8 equals 3x minus 22. Add 22 to both sides, and I get 3x equals 30, x equals 10. Okay, so I solve for x in this situation. Now I need to solve for y. So what I could do is a couple different things. I could take x and I could plug it in here, and I could say 3x plus 8 equals 3 times 10 plus 8, and that gives me 38 degrees. So that tells me that this angle is equal to 38 degrees, and this angle is equal to 38 degrees. So now I know that since this is a linear pair, I could say 180 minus 38 equals, that's 142 degrees. Now this angle here is then going to equal 142 degrees. So now I can set 3y plus 7 equal to 142 degrees. Subtract 7 from both sides. 3y equals 135, and I divide by 3. Y is going to equal, let's double check our math rather than just guess. 3 goes into 13 4 times with 1 left over. 3 goes into 15 5 times. Y equals 45. Not degrees, just 45. Okay, so that's one way to solve for y. Another way to solve for y would be to say this angle plus this angle equals 180. And we could solve for y that way. So let's take a quick peek at what that would look like. So we know that 38 degrees plus 3y plus 7 equals 180. This is 38, and this is 3y plus 7. Now we combine our like terms, these two together here. We have 3y plus 45 equals 180. Subtract 45. 3y equals 135, and y equals 45. So since we got the same answer, we know that we did it right. But this is just two different ways to solve for y. Just wanted you to see that, not one specific way. There's a couple varieties that we can do in here. Okay, that's the end of 2.4. Please know that your homework for 2.4 is in Schoology, and that one's going to be due on Monday. Sorry, Tuesday. We don't have school on Monday. So go ahead and jump into that. Email me if you have any questions. Otherwise, have a great weekend, and hope things go well for you. Enjoy the long break. You've earned it.